The insertion sort algorithm takes one value from an unsorted part of the array at a time, and now we insert this into the correct place in the sorted part of the array. In this lesson, we're going to look at how to implement the insertion sort algorithm. My name is Mildred. When we want to implement the insertion sort, we want to think about how to do this so that we take a value and then we insert it into the correct place. So we'll have two parts of the same array. One part will be the sorted part and the other will be the unsorted part. Every time you want to create your functions, as always, you want to make sure you have values to sort or it is not already sorted, right? But we're not doing those checks because we just want to see the implementation of it. So I'll just write the insertion sort and then I'm going to be passing in an array into this. We want to assume that the first one is sorted, and then we want to look at the next element and compare it to the sorted part. It's almost similar to what we had in the selection sort. We want to move that next element in that correct part of the sorted part of the item, and then we want to repeat these steps until completely sorted. So like always, let's get the length of the array. Okay, we can do the length -1 or we can just leave it like this to n. Now we want to have an outer loop that says we can actually do it in a different way from the way we did the selection sort. Let's say for I in range. So now, since we assume that the first one is sorted, we want to start from the second item, which is at index position 1 up until n. Okay, so we start from the second part up until the length of the array. Now in the range function, right, when we specify the stop position, is always exclusive, right? So we'll do to n. If we want the stop position inclusive, we'll have to add +1. So assuming I subtracted 1 here, I would have had to add +1 here because the last is not inclusive. All right, so I will put let's get the current element to be inserted. Let's call it the key, and we're going to say the current element to be inserted is at index position I, right? And when we want to get the index of the last sorted element, so the index will be j is equal to I -1. Okay, so we're getting the index of the last sorted, which is the current pointer of the iterator, -1, the one before it is the last index of the sorted part, right? And so we want to say, let's use a while loop for this one. Let's say while j, which is the index position of the last sorted element, is greater than or equal to 0, right? And the item held at that jth index is greater than the item held at the current iteration, so which is key, so it's greater than the item held at the current iterator. So we want to use the first iteration here, like we assume that the first is already sorted, and so we save that in the variable. You can put it as first item, but I just put it as key, right? And we want to make sure that the iterator is not on 0. If it's on 0, you can't go backwards to a negative number. So you want to make sure that the j value is greater or equal to 0. So if you have one item, this loop will terminate because it will not meet the condition. So we're getting here the last index of the sorted part, and then we'll say the item held at the index position of that last index at the sorted part, if it is greater than the item held at the current iteration of the loop, which is stored in key, we want to swap, right? So we'll say the item held at, so if it's greater than the item here, we want to make sure that so what we're saying here is that if the item held at the last index, the last sorted item right now, is greater than the item held in the current iteration of the loop, which means it's not smaller, we want to make sure that we move forward and say that the array j+1 now will now be equal to, so the current iteration now, which is j+1, will now be equal to the item held at, so we're swapping it at array j, right? And then we want to say j now will be equal to j -1, so we can say j minus equal 1, all right? And then we'll say array j+1 will now be equal to the key, so this will insert it in the correct position, and at the end of it we want to return, so we'll do this outside the loop, and then we want to return the array. So let me explain this again. For the insertion sort, we assume the first one is sorted, right? And then we loop through the rest of the items, starting from the second index position, which is the second item, to the last item. We loop through it we already set the first one to be the last of the sorted part, which is the key. The key holds the value that is on the current iteration. Now we want to have an iterator that we want to use, and we want this iterator to be equal to the last index position for the sorted part. So we say j is equal to I minus 1. So where I is pointing to is the current item that I wants to pick and compare, and j is going to be the last part because we don't want to resort the sorted part. So we want to make sure that when we put j at the last sorted index, it is not less than 0. So j has to be greater than 0 so that we'll know that we have items to sort. And the item held at the current index, so that index of j, the item held there, if it's greater than the item that we set has the key here, which is the item at the current iteration of the loop. If it's greater, we want to now set that array j to be equal to the next, so we are swapping it to be equal to the next, and so we can move it to the correct position in the part of the sorted one. All right, and once we do that, we now, when we say j minus equal 1, we will do that, we now set the key to be the next value, like that, and we continue this in the loop and return at the end. Let's see if this works. So let's just have some numbers. Let's have 65, 44. Okay, and now we want to print the insert sort, and in a pair of parentheses we pass in the numbers, right? So let's run this and we'll see that this sorts completely. So our algorithm works. You can think about this in a different way. Write out the algorithm, think about it differently, and see if you have a different way of implementing this that is more efficient. So this is where we end this lesson. Thank you and see you next week.